Let's get started. I'm Ewan Cameron. I'm joined up at the front here by Justin and Will, and they're from the Runtime development team. And we're going to talk about building offline apps and some of the functionality that you can put into your offline apps, how you build them, but we're also going to talk about how you use other aspects of the platform to create the data that goes into your applications, because there's choices available to you depending on whether you're starting from the desktop or you're starting from online. So we'll cover the workflows and the data kind of in the first section, and then we'll get into using the APIs and seeing what you can do with the APIs. And then at the end, we'll actually spend a little bit of time talking about the next release of the Runtime, which we have codenamed Quartz, because there's a lot of new capabilities coming in the Quartz release. So the majority of the talk is really about what you can do right now if you go to the developer's website, you download the SDKs and start work, and then we'll finish it with a little bit at the end, looking into the very near future with the Quartz release. So when we talk about app capabilities and building offline apps, we're really talking about building an application that is disconnected from the ArcGIS platform, and what can you do when you're disconnected? And that disconnect can happen in a number of ways. It can be sort of a partial disconnect where you're connected, you know you're going to go offline, so you take content offline, go into the field, do some work, it may be editing features, you come back, and then you reconnect and synchronize. Or it could be much more sort of permanent disconnect where your application's never really connected at any point to online or to a server. All the data gets loaded onto the device or onto the machine ahead of time, and then you're permanently disconnected. All of these are definitely supported. And when we talk about what we can do, obviously it's working with maps. It's looking at the content of your map, all the various different layer types, querying the data, editing the features. You can synchronize these edits back to the server or when you get a connection. You can also find locations and addresses using geocoding technology. That's all built into the runtime. You can get directions, driving directions. And we've got this notion of a pre-planned workflow or a on-demand workflow. Pre-planned is where you do quite a bit of maybe data preparation up front, and then you get it onto your device, you go out into the field, and you come back. On-demand is where your user at any time decides to go offline, and they just suck the data down onto their device, and it's very flexible, but if you're dealing with large numbers of users, it's maybe not as scalable as doing the pre-planned workflow. So depending on your use cases, and we'll get into the details, you might want to think about a pre-planned or support an on-demand workflow. And occasionally connected, that's really, I've talked about that already. And all the Runtime SDKs support offline use of the platform. So when you're working offline, you probably are going to interact with maybe only one of these initially, but I think over time you'll start to think about all aspects of the platform and what it means to go offline from that, whether it's online and you're working with hosted content, or it's server data that you want to take offline and work disconnected, or whether it's just data that you want to move from your desktop to your device, do work in the field, and then come back into the desktop, sort of the classic ArcPad style workflow. All aspects are supported with Runtime, and increasingly we're seeing customers mix and match a lot of these in their solutions. But there's a number of new workflows that you make use of, and these workflows are we're going to cover right now. So the first one is you're online. So you've got your data hosted in the online. It could be features in some feature stores hosted online. You could be making use of our Basemaps as part of your online application. And you basically author a map, pulling that data together, whether a combination of our Basemaps with your hosted features. You author that map, and then what you can do, you prepare that map. There's a few things that you need to do to the data in order to enable it to be taken offline. By default, all the data typically wants to just stay in the cloud. but you can enable it to go offline. Once you've done that, you can build an application that downloads that data onto your device, and when you're on the device, you can view it, query it, analyze it, and edit it if it's the feature data. And then at any point, when you have a connection to your online services, you can synchronize changes. You can push changes from your device up to the cloud. You can pull down changes that have happened in the cloud onto your device, or you can do both. A two-way sync is probably the most common way of doing that. So what I'd like to do now is pass over to Justin, and he's got a very quick demo on working with hosted services and what you need to do to these services in order to enable them to work offline.
All right, thanks, Ewan. So first we're going to start off with taking a look at a couple of different ways you can actually create hosted services to use inside of your runtime applications. And one of the things that we're going to start with is we're going to start with on the developer site. And on the developer site, we have a whole place where you can go and manage layers from your content inside of your organization. And if I would have signed in already, it would have just shown up. But so now that we have our layers page and we're logged in, we could see what layers we actually would have here. And I only have one small test layer inside of this organization. So I want to create some new data. And new in the last couple of weeks is a redesigned Create New Layer tab. And from there, we have a much more streamlined process than what we had before. We can add in a layer name, and we actually get to see right here what the URL that we're going to need for putting inside of our application or inside of our map. Of course, we have to put in our tabs or our tags. We can specify our geometry. We can start to add our fields here. We need to have at least one of those. We can mark them if they need to be required. And then, I think this is the best part, because instead of having to go find some hidden options down in some other items details page, right here, when you create your layer, we can say if we want to enable it to take it offline, and if we want to have attachments for that feature. And then we can simply hit the create button. And this is going off behind the scenes, is spinning up a service inside of my organization, making an empty service, giving it some default symbology, and now we have an items page, which we can start to do work with it. And the first thing that we could do is, if we were already happy with it, we could just take this URL right here, and we could go and use it inside of our application. Or we could open it up in ArcGIS Online, and we could start to modify things about that. We could start to change the visualization, for example, and actually, rather than I think the blue dot that it's going to give it by default, we could change the symbology to be something else that would be better for our data that we're going to collect. And then from here, we can also start to actually collect that data as well. For developers, it's sometimes very interesting to see how much are your services being used. And right here, you can take a look at the usage page, and it'll tell you the amount of data, the amount of requests, that kind of stuff, some basic usage information for that service. So that's great if you're creating kind of a new service from scratch and you want to define the all of the attributes that are going into it. But sometimes you might already have data that you just want to put into the cloud and make it usable inside of your apps. So of course, inside of my content from ArcGIS Online, there's always the add from my computer. And from here, I can easily choose a file from many different formats, shape files, CSV, the list goes on and on. And when I do that, I can choose my shapefile. And when I go to open it up, it recognizes that it's a shapefile. And then right here, I get a nice option to publish this file as a hosted service. So once it's published as a hosted service, sync can be enabled on it as well. And then you can use that data right away offline inside of your runtime apps. So the last thing, that's all talking about feature data and being able to enable things for sync. But one of the other important parts of taking your map offline is being able to use Basemaps to go along with that. And we have enabled all of our Esri Basemaps to be taken offline. So we've kind of enabled the export tiles capability. So from our ArcGIS runtime documentation pages, we have a nice document that talks all about creating maps offline. And inside there, there's a great link that shows you how to get to our tiled basemaps. And this is a group that lists all of the URLs as items for all of the base maps from Esri that have the export tiles capability enabled. And you can use that inside of your app to take them offline. Back to you, Ewan.
Okay, thanks, Justin. This is a very quick demo there. But there's just that one extra checkbox that you've got to do to enable that feature service to be taken offline. And if you've got tiled map services of your own, you need to make sure that you enable them for export. When you're working with data that you find online, you've got to always review the usage restrictions on it. Some data providers do not want you to take their data and use it offline. It's against their license agreement that they have with you, the user of the data. All of the Esri base maps are fully enabled for offline use for you and your customers. As long as you're a customer of Esri, you can take our basemap services offline for any length of time. There's no time limit on the basemaps that you can take offline. So that's something that's good, but we had to negotiate that with our data providers. So if you're using content from other data providers, please make sure you review the restrictions. We showed you taking features and basemaps offline and how you enabled that. The geocoding and the routing services that are provided by Esri cannot be taken offline. And there are some business restrictions there, but actually it's more of a technical restriction at the moment. We can't take a very large area and clip out a small piece of a geocoder to take it offline. Same with a street network. That's something that we're considering doing into the future, but it's not on our technical roadmap. At the moment, we'd be interested to hear from anybody who thinks that's a requirement. However, you can still get your geocoding and routing offline, but you've got to use one of the other workflows that we're going to show you very shortly. All right, so that was online. What about content that's sitting in ArcGIS server? It's kind of similar, certainly from the user experience side of things. When you are offline, it's very similar to online, but the data preparation is a little bit different. You start in ArcGIS desktop, and you author your map. And you take that map and you publish it to the server. And when it publishes up to the server, there's a couple of options that you can do as a user. You can decide to publish it by value, in which case you get a copy of the data and the map being moved onto the server, or you can do it published by reference. And that's important to know and remember in your workflow. And publishing by reference keeps the map and the data sitting where on the databases that you would directly connect to from ArcGIS desktop. The client downloads the data, same as it did with the hosted service, and works with it, and it works with it in a very similar way. It views it, queries it, analyzes it, and edits with it, and you can synchronize. And the synchronization options are the same. It can be one-way in either direction or two-way sync, but the syncing happens to where the server thinks it's got the data or has the data. So if you've published by value, it'll synchronize the data on the server, not the data that the desktop is looking at. If you've published it by reference, the syncing happens to the data that everybody is looking at on the back end. So think about that in your workflow. When you're working with desktop, you have some more options, but there's a little bit of a restriction here. So with desktop, you're working with your maps and your vector and your raster data, but you're also working with geocoding, locators, and you're working with networks. And with desktop, you can author a map. And your map can contain vector data, raster data, it can contain locators, and it can contain network layers inside of it. And when you go through an operation in ArcMap called prepare runtime content, that operation packages up all of that content and gets it into a form that can then be side-loaded onto your device for use out in the field. Now it's provisioned onto the device, and now it's on the device. You can view, edit, analyze. You can also geocode, and you can get driving directions. You can't edit the data. That's not strictly speaking true. You can edit the data online, on your device, but there's no automatic way of getting these changes back into ArcGIS desktop. So that's something, it's really for a read-only push to get sort of maps out into the field that have sort of these capabilities. All right, so back to Justin, and he's going to show some of the options within ArcMap.
Okay, so first we're going to start with taking a look at some of the steps from the first workflow Ewan was talking about. So this is going to be about creating services that you can then take offline and use inside of your application. So the first thing for creating feature services that can go offline is you need to start with data that's inside of an enterprise geodatabase. And that's what I have here on the side in the catalog view. And I can go down here and I can find a service a feature class that I created. There's a few things that you need to do to make sure that feature service can be used offline. Underneath the feature class, I can go to the Manage tab, and I need to make sure I add global IDs to that feature class. Ooh, I get sound effects, nice. Should have had some better ones prepared. So this should be relatively quick because there shouldn't be any features in there, but if you do have a lot of features, or apparently if the network's not going to like me, it's going to take a minute to add global IDs. Now, one of the things to actually mention about this is global IDs are important for if you're adding attachments to a feature class, like we can do right now, or if you have relationships to other tables. They need to be global ID-based relationships, not object ID-based relationships. So for any attachments, any feature classes you might have created in the past where there was an object ID-based for attachments, you need to actually convert those to be global ID-based. And again, under the Manage tab, since we have global IDs added, we can just hit Create Attachments. Now finally, the last thing that we need to do to enable our data to go offline is to be able to enable archiving. Again, it's another option underneath of the Manage tab that turns on archiving for that data set. That's the preferred way to work with feature classes offline. We do support version data as well, but that's generally, it doesn't quite scale quite as well as the archive data, but we do have the capabilities of being able to use version data offline. But preferred, if we go into Manage, and we can just enable archiving. And with that, we've actually finished prepping the feature class to be able to be used. We can construct our map document out of that, and actually I've got another one right here already put together. And now we can actually publish our service. So just like we publish any other feature service, we go to the Share As menu, select As a Service, and then go to Publish. And then as we get the options for publishing to come up here, we can go under the capabilities, make sure we enable feature access. And then under feature access, there's just one operational property. You just need to click Enable Sync. And with that, after the service is published, now you'll be able to take that offline. So that covers our features. We also need to be able to publish map services that have the export tiles capability enabled as well. So this is just very simple data that I have, and I want to publish it to use it as a tile layer offline inside of my app. So there's nothing special we actually need to do to pre-process the data here or enable anything on the data. It's more when we actually enable and publish our service where we need to do a few things. So under Services, same thing, Publish. And this time, when we get our service options, we're going to go to the Caching tab, and we're going to enable caching for that. And we're just going to leave the basic tiling scheme, but you could have your own custom tiling schemes if you needed to, and you can adjust the level of details that you want, but we're just going to go with the default one that we use in ArcGIS Online. And then next, you get to go to Advanced Settings, and then really, really advanced settings, and you can click on the Allow Clients to Export Cache Tiles. And then you can also set a limit for the number of tiles that you want to allow to take offline. Now, we've definitely done this with our base maps that we expose, all the Esri base maps. We've put a 100,000 tile limit on this. And this is the number that we thought kind of had a good balance of the area you could take offline versus the load you're putting on the service versus how giant a tile package you were going to be generating to download over the network. But this can be adjusted on your own services to be more or less than that. And then we simply publish our service, and we're ready to use it offline. So The next workflow that we're going to take a look at, so that covers off kind of the capabilities to get services working. But as Ewan said, we also have a desktop workflow, which definitely can be used in a number of cases where you want to provision, say, read-only data to a large number of clients, or if you want to prepare networks and locators to be used offline in the field as well. So similar map document to what I had before. I have a number of layers that I've added here, and they're all kind of my operational layers. So things like my wells, my distribution lines, and a few other things. Also, though, we'll see that I've added in a transportation network. So this brings in the routing capabilities into my map. And I've added in a base map group and dumped those 3 base map layers that we saw in the previous map document into them. So this is really kind of setting up our data in such a way that when we run the Create Runtime Content tool, it allows us to select some options about how we'd like to package that for offline use. And then also in my document, I've added in a custom street locator as well. So with the data prepared, we need to go to the File, Share As menu to share with Create Runtime Content. Now, this is actually what you'll see the first time you go here. There is no option to do this. So to enable it, you need to go to Customize, ArcMap Options, and then on the Sharing tab, enable the ArcGIS Runtime tools. And once those tools are enabled, on the Share As menu, you now have an option for Create Runtime Content, and we also have our tile package option as well if you're just doing base maps. So if we run the Create Runtime Content tool, we can choose the output folder location. We can make some choices about the data now we want to include inside of our content. So we want to include all of our feature and tabular data, and this is taking simple features. So if you have more complex things, topologies, other things, they get dumbed down. As long as they can be accessed and used as simple features, we can include them inside of the content that you get. We also do have an option here that says optimize size for viewing. So that's the size of the output data. And we do a few things here where we strip off all of the attributes not being used by definition queries or for visualization by the renderers, and we reduce the precision of the data a little bit. And that actually makes a big difference in terms of the final output size. If you want to be able to make sure you have all of your attributes there, or you don't want the precision, then don't check the box. But if it's just strictly to kind of have some additional read-only base map data that's not tiled, this is a good way to kind of reduce the size for moving it around. On our base map tab, it's going to look very similar to the options that we had when we were actually publishing a service. We select we want to include the base map, and then we have the same choices about tiling scheme where we can specify our own level of details to cache, etc. Network data, because we've included that network data set in our map document, we have the option to say yes, include it in our output. And the same on the locator, because we have a custom one there, we can include the locator in the package as well. So we can analyze that, probably get some warnings about the scale, visibility on my map and a couple other things, and then click the share button. And what we get when we finish that share operation is we actually get a folder of output. And inside of that folder, we can see that we have basically what would be the contents of a tile package, so a compressed cache of tiles that have been cooked for you. You have your database in a mobile geodatabase format, along with next to it our transportation network, all the information that's needed to actually generate routes on the client side, and our locator that's all been enabled for runtime use. So they can now take that folder of data and you could sideload that onto a device, or you could stage that somewhere on a web server to be downloaded on the client, and then bring that on to your device and bring it back to life inside of your application. With that, back to you, Ewan.
All right, thanks, Justin. Okay, so we've seen a number of ways that you can get data from the platform onto the device that's going to be running the runtime application. And we typically see when this is done, it's kind of a mixing and matching approach that gets done. Our online base maps are often the base maps that people want to take offline because they're all prepared, they're ready to use, they're updated on a regular basis. It makes it pretty straightforward. But you have your own feature data that you want to be able to edit or interact with. And these can come from feature services. And then geocoding and routing, if you want that in your application, you prepare that with ArcMap. And so they all blend together to the final application that the user uses. So it's a very common approach. There's lots of ways that you can optimize this data provisioning process. If you always ask and support this on-demand mode where you're just asking for the server, please give me these features in this area at the start of the day, I go out into the field and I do some work. That works, and it's relatively fast. But if you're in an organization that has 100 field crews or 1,000 field crews, and they all do that at the same time, 9 o'clock in the morning, it can be a demand on the server. And it's not possibly the most optimal way of doing that. So a way to do that would be to sort of do a little bit of pre-planning there and a little bit of pre-planned workflow where you can potentially generate the cache once, the package once on the server. The field crews come in the morning and they download the pre-generated cache and then they just register it with the server on their device. And then the server now knows it's got all these copies out there and they can go out into the field. Or you can sideload the data. And if it doesn't update very often, that side loading could maybe happen once a month, once every quarter, depending on when the base maps are changing. That dictates when you actually have to side load the base map content on. So think really hard about your use cases and use the various options that are available to optimize that workflow. So working with base maps offline, we're going to actually get into some of the code that you would have to write here. So ArcGIS, you can create tile caches with ArcGIS. You saw Justin really doing that just 2 minutes ago. You can sideload these on. You can talk to our online hosted base maps. And here's the URL, tiledbasemaps.arcgis.com. And depending on the specific base map you want, there's the rest of the URL gets filled in. And you just start working with it and pulling down content. The services have their size limited, as Justin pointed out. So that's set on the back end. As a client, you don't get to choose how big that limit is. So as a client, you've always got to check to make sure that the area that you want to take offline will be supported. And you do that by writing code like this. So this is how you take code offline. You use the task, export tile cache task. You pass in the URL, and if you want to know what that URL is for our services, you go to the group that Justin pointed out earlier. You put that in there, and that creates the task. Then you create your parameters object for the task, which is going to tell the task really what to do. And that parameters object will say the level of details that you want to take off, but very importantly, it sets the area of interest, the geometry, the extent that you want to take offline. And at that point, we recommend that you call the next method, which is estimate tile cache size. And that'll come back, and it will tell you how big that cache is going to be. So even though the server allows you to take the area offline, it may not be practical based on your network connectivity. If your Wi-Fi connection or your hardline connected, you can take a very large cache offline. It doesn't take very long to download. But if you're connected through 3G or worse, you don't want your users sitting for hours waiting for their cache to download. So you get that estimate tile cache. And it's an estimation, but it's a pretty good accurate estimation. But then if you build a user experience that says, yes, that user's accepted taking 50 megabytes of cache off, you can start the process by calling export tile cache. And at that point, you can use that estimated tile cache size to help you provide some user experience to your user as the downloading is happening. So that's working with tiles. What about operational data? That's really features from feature services. You can work with features in a read-only mode, where you just download the features to the device and you work with them, and you can update the features by syncing in a one-way direction every day where you're pulling down changes from the server, so you're just getting the most up-to-date map on your device before you go out into the field. And these features can be related features and related tables. They can contain attachments. They can have their pop-ups. They can come from a versioned database or a non-versioned database. Non-versioned databases perform better, are more scalable, because there's less work for the server to do, especially when it comes to the editing and the conflict resolution, etc. But we do support them. But increasingly, we're seeing a lot of people wanting to edit their features outside in the field. So here you can download them again onto your device. The runtime allows you to edit them. They're stored locally, actually stored in a mobile geodatabase, which is implemented using SQLite. And we keep track of any of the deletes and additions and modifications. And then you can synchronize with the server. And you can synchronize in a variety of ways. So when you synchronize with that server, you can choose to do a per layer sync or a per geodatabase sync, where it does all the feature classes in the geodatabase. And you have control over the sync direction. You can just download the changes if you want to be really a read-only mode and you just want the most up-to-date data from the server. You can do an upload only, where you're not really caring about what's happening on the server. You just want to push your changes back to the server. And then you can do a two-way sync where you download and upload. So how does that actually work in code? So let's have a look at some kind of pseudocode here. You start with a task. That's the way that we do a lot of our operations, our long-running sort of asynchronous operations with the server. We work with tasks. So we have the geodatabase sync task. You can start creating your parameters object for the sync task, that like the extent, what feature classes you want. And when you tell the sync task to go and fetch the features, it gives you a geodatabase. Excuse me. And from the geodatabase, you get a geodatabase feature table. That's the table that has the features. And then from the feature table, you can get features. And you can draw them in your map. You can make edits to them. And a geodatabase feature inherits some feature, which is similar to a graphic. And then if you want to render, and you can do all of this work without drawing the features. You could just make raw edits to this table, and in theory, you could synchronize these back. But typically, people want to draw them on a map, and when you draw them on the map, you use a feature layer. And the feature layer inherits there from layer. You can see the various methods there that you call. You've got add, update, delete, query, get fields. They're on feature table. Geodatabase feature table has a few specific things that are specific to a geodatabase feature table, as opposed to some of the other feature table types that we have. So then this is an animation on how the actual sync works. So we have the feature service. It's got sync enabled. And we call generate geodatabase. And we get a mobile geodatabase generated on the server and then downloaded to the client. And then you can then start working with that, with your editing, adding, deleting, modifying features. And then when you want to make a synchronization action, all you really need to do is call sync. It's a very simple call to make, but a lot happens at that point. So when you call sync, the runtime goes and looks in the table, or tables in the geodatabase, looking for all the changes, and it prepares a very small delta geodatabase, which is done on the client, and then it uploads that to the service. And so the delta gets uploaded to the server takes that, looks at all the content, looks at the timestamps on the features, and then applies them to the database on the server side. And it then prepares a result to tell the client what has happened with that sync operation. Have some of the synchronization edits failed? What's the reason behind the failure? Has it all been successful? And then the runtime retrieves that response and then applies that response to the database. If you're doing a two-way sync, for instance, you're going to get features that have changed on the server back down to you, which we then apply into the table. So all this happens, but it's all tied up behind that one method. And if you can see that if any one action of that fails, for one reason or another, we're uploading data to the service when our network connectivity drops. Or the process has happened, but it's a very large sink, it's on the server, the server is applying the changes, but then our application, if it's on an iPhone, goes into the background because I've decided to check my email, and the OS kills the application, etc. Lots of things can stop this process happening from in one sort of discrete sort of set of operations. But the important thing to realize is that your edits, your changes are never lost. Because all that you need to do in your application as a developer, if you're not sure if you've finished because something went wrong and your application got taken out and put into the background, all you could do is call sync again. And the worst case scenario is it's already got that delta there waiting. It knows no changes have happened since the last time the delta was created. It's just going to upload the delta again. And so maybe there's a little bit of a waste because we've uploaded the delta twice because we didn't know if it got to the server correctly or not. But your data isn't impacted. There's no data loss no matter what happens within this call. You as a developer just call sync a second time and it's all taken care of for you. All right. So let's have a look at the feature layer here. We've got the feature layer. Has a feature table associated with it. So feature layer is about drawing, and feature table is about data access. And feature table has add, update, and delete, and query. Now, feature table is really a base class that all of our specific implementations inherit from. We have a feature table for shapefiles. We have a feature table for OGC packages as well. But we have a feature table, as we saw, for a Geodatabase feature table. Geodatabase feature tables are for feature tables that are locally on the device, stored in that SQLite database. But the other thing that we've done, we have a feature table implementation for features coming from a service. So we don't have a special layer type for dealing with feature service content. It's just another table in the developer's sort of object model. And the nice thing about that is, as a developer, if you're working with content coming from a service, features, or you're working with content that's being stored locally on your device, your code is exactly the same, or the vast majority if it is. It's just features in a table. The only thing that's a little bit different is the editing transaction model. So for Geodatabase features, you can, the add, update, and delete is on the feature table, and these changes are just being put straight into the table, as you would expect. If you're working on a feature service table, all the changes are cached locally on the device for short periods of time. We don't always write them back to the service because that wouldn't be very efficient. To get your changes from the device back to the feature service, you need to call apply edits. That's the only coding difference that you have between local content and content being streamed from a feature service. So it does make it easy to write these applications that are in a sort of that partial connect mode. So you can be talking to a service, you could take your data offline, you could be talking to data on your device. The code's exactly the same, apart from that one slight change. If you're online, just call apply edits at the end of the session, or ideally after a logical set of operations. It might just be when you finish editing one feature, you always apply edits. But it's in your control as a developer. All right, so this time I'm going to hand over to Will for some demos of feature service and feature editing.
Thanks, Ewan. So let's take a look at an application that shows you some of the feature access and sync and editing workflows, just so you can kind of understand it. Here we have the Qt QML sample application running on Mac. As you can see, it's delightfully localized for my native language. And this is currently online. You can see a little switcher here. It's currently online, so we're currently using a feature service table to render these features on the map. And you can see I can zoom in and out. Just so that you believe me that it is a feature service, I'll show you the same application here in ArcGIS Online using exactly the same feature service, so you can see the same features that I've got there online. So what I'm going to do now, though, is generate a geodatabase. So this goes off and creates a geodatabase sync task. You can see the status running at the bottom here. Tells you what's going on with that task. It's getting updates every time it's hitting the endpoint to see how that task is getting along, and you can use that to provide a UI to your users. And then this gives me a geodatabase that I can then work with offline. So we'll give it a little bit of time to tick along. It was very quick. Oh yeah, and there you go. And now it's done. So it now is in the offline mode. You can see that it's changed to offline here. So now I could, in fact, turn my Wi-Fi off. I won't. You'll just have to believe me that I'm offline because my laptop and Wi-Fi don't play particularly nicely together today. But I can now pan and zoom, and I can now make edits. So I'm going to select a feature here, and I'm going to move him over there. Remember that, because I'm going to go back to the browser in a second. And I'll take this guy here, and I'll put him over there. So you can perform all these edits, and as I'm making these edits, you can see in the web that right now they haven't been committed. So the other person who's using this feature service is not seeing my edits yet, because I'm obviously working offline. But I can get to the point where I decide to sync those edits, and you can see the progress is ticking along at the bottom here. And this is doing what Ewan says, taking that delta and applying it to the service, and that's completed. So now when I go to this, you should see the red dot and the cross that I moved are now available to the people who are consuming that feature service elsewhere from the platform. So you can kind of see how that workflow works. So let's have a quick look at the code. I'm not going to go into too much detail. So this is QML code. It's actually essentially JavaScript, so it's relatively easy to read. If I can find it, here we go. So this is the generate geodatabase parameters object that I've initialized essentially with a feature service info. So I've gone to when we do that, this is a convenience method that creates default parameters for you. It syncs all layers by direction, and you don't have to go through and add layer by layer properties to your parameters object. You just give it the feature service info, and we do it for you. I then set the extent of the parameters based on my map extent. I say that I don't want to return attachments. It keeps the geodatabase nice and small, which is why the demo was nice and quick. And then with a geodatabase sync task that I've created with the URL of the feature service, I call generate geodatabase with my parameters, and then I give it a path of where I want that geodatabase to live on disk. So that goes off and creates the geodatabase. There's some code at the top here which creates either a geodatabase feature table or a geodatabase feature service table. So when it switched from offline to online, you probably didn't even notice it, but it actually threw away one layer using the service feature table and added a new layer using the geodatabase feature table. But this happens so quickly that you don't really notice. But that's the pattern. So then as a developer, I write my editing logic. I'm not going to show you that in here. The editing logic, as Ewan says, is the same between online and offline because it's against the feature table API. So I call add, update, delete, edit my features. And then, because I know I'm offline, I have to do a different thing. I have to create a geodatabase sync task and call sync. And I pass in some sync parameters. I actually get the sync parameters from the geodatabase. Again, convenience method, just syncs all layers bidirectional. Don't need to worry about it. And I tell it the geodatabase that I actually want to sync. And then there's code in here to obviously handle all of the status updates, and we have these callback listeners of when the status has changed that allow you to get progress updates and show those changes going along to your users. What I'll quickly do as well, quick unplanned demo. What I'll do is just quickly show you how to download a tile cache, just to talk about the estimate and tile cache API. Here's an application that works against our tiled services. I've got some service info for the tiled layer that it's working against. I'm going to zoom to an extent and just show you that the estimate starts a task. And again, look at that, came back really quickly. Earlier it was actually a lot slower, so that's a bonus. But you call estimate, it basically takes your current extent and it tells you how big the tile package is going to be for that area. And if you think that's acceptable, that's going to be bigger. Don't do that. So yeah, if you think that estimate is okay, let's just do that one more time. You can then start, and it creates a task, and it will actually then go and generate those tiles and download it locally. And the source code for that is very, very similar. I'm not going to show you that right now, but basically you create the task, you pass in the extent and the LODs that you want, you call estimate. If it's good, you then just use those same parameters that you use for the estimate task, and you pass it into the sync task. Oh, look, and it actually works, kind of. Yeah, don't worry, Liz. We'll just move back to the slides.
That's the trouble with ad hoc demos. All right. Okay, so that was offline editing. Now, one of the things that people who have worked with versioned data before always ask is, how does conflict detection work? So the conflict detection model that we have for offline editing and synchronization is exactly the same conflict detection model that we have for all of feature service editing, and that's last in wins. So there isn't really any conflict detection, but that's a good thing because it scales really well. Whereas if you have 1,000 editors out in the field and you've got to deal with conflict detection, can you imagine how hard that would be on the back end? And so that's why we've purposefully done that. So it's last in wins. And it's last in on when the sync happens, not when the original edit happened on the feature. We just take that data and we apply it to the database on the server as if the edits are being made right at that moment in time. So that's our sort of policy there. And then knowing that, you can potentially divide your workflow areas into so that conflict doesn't really happen. If you are using version databases and these are going into a specific version, then obviously you still have that option as part of your workflow. But bear in mind, editing on the version databases ultimately will not scale as well as when you're on non-versioned data that's just been enabled for archiving that Justin showed you. All right, working with locators offline, that was features. You prepare them for offline use in the desktop. You then program against them in the runtime. And the way that you program against an offline locator in the runtime is exactly the same as the way that you program against an online locator in the runtime. The programming patterns are very, very similar. Just like we've made working with features online and offline similar, we've done the same thing for locators. The one thing you will notice, though, is because you're working with the data locally on the device and it's not making network requests every time you want to do a geocode or a reverse geocode, you get an extremely high performance on the device. So here's the pseudocode for Locator. You create the locator. Instead of passing in a URL, you pass in a path to the file that has the locator on it on your device. You use a parameters object, which is how you pass information into that locator. So you want to find this particular address, and then you call find address. And that is the same code that you would call if you're on an online or offline locator. And this reverse geocode is very similar. You just call find location, you pass in a point, and it returns to you an address. Working with networks, almost identical to working with locators. You prepare the network for use on your runtime application using ArcMap in the desktop workflow. Programming pattern is the same. And again, because the data is local on your device and there's no network request, generating driving directions is extremely fast inside of the runtime. And the pseudocode here is really quite similar. You create your task, you create your parameters object, and you call solve on the task, and it generates the stops. Now, the actual routing engine is pretty sophisticated. So it's not just point-to-point routing. You can have multi-stop routing. You can optimize the stops. You can have barriers. The barriers can be points, lines, or polygons. And so it's a pretty sophisticated engine that's running inside of the runtime. And both of these best seen with a demo. So over to Justin.
Yeah, microphone might help just a little bit. Okay, so we're going to take a quick look at a few of the things that you can do with routing and geocoding inside of the runtime. And actually today we're going to do this with the OS X sample application. And while Will chose to look at some nice, easy to read JavaScript, I think we'll take a look at Objective-C today just to make it a little more difficult. So we're going to start off with looking at our locators doing geocoding. And if I, in the sample, just hold down, and then I can just move the cursor around the map. And as you can see, as Ewan said, you get very, very good performance because it's just hitting a locator that's living on my machine. And it can keep up, and if Will was doing it, he'd have a witty sound effect to go along with it, but yeah. But really, really good performance because everything is all happening locally. And then with our geocoding, we just have an address here somewhere in San Francisco, and then zooms into that point. So not a particularly glamorous demo, but you can see great performance, and that's the main takeaway from it. So let's go over and we'll start to take a look at a little bit of the code, hopefully. Perfect. So it's going to be a very familiar pattern. Will's already shown it. Ewan's talked about it a little bit inside of with some pseudocode. This is a task pattern that we have throughout the runtime SDKs. And so we're going to see an example of it here where the first thing that we need to do at the beginning of our application is we need to set up our locator, just giving it the path to where it lives on disk. Next, we'll take a look and see how we did the reverse geocode to begin with. So, on our did tap and hold from our map view, we can see that all we have to do is simply call address for location, passing it in the map point of where our cursor is at that time. And when that operation completes, when it's actually found an address candidate for that, we can show a call out at the location that was found. And it's just, or at the location that we had with the address that was found. And very simply, we can go and take a look at the candidate address that comes back, and we can pull out things like the street, the city, the state, and that's what we were showing in our call out. So very, very easily you can put together reverse geocodes in your app. For doing geocoding, we can set up, first we take the string value from our input field that we have, and we need to set up our parameters before we make the call. So here we're simply just setting up that it's a single line of input that's coming in, what outfields that we're looking for, and if a spatial reference as well to pass in. And then once we have our parameter object set up, we just call location for addresses. And that kicks off going and searching for matching locations. When we get our results back, we go through, and you can potentially get a number of candidate results. You don't just get one back in all cases. So we're going to loop through all of the address candidates that we actually get, but each of them come back with a score. So you can go through and you can pull out the ones with the highest score. And that kind of dictates, depending on how your locator was created, things like, was it matched purely just on the city, or was it actually matched on the actual street numbers? And that will affect the score that it gets. But that's all about how you created that locator inside of desktop before it was enabled for runtime use. And then once we've looped through, we can take a look at different things like our actual graphic from the candidate, and we can show that inside of our graphic layer that we have on the map. So next we can move over and we can take a look at offline routing. We have a nice little simple demo of here in San Diego. And I can add a start location somewhere close to where we are. And then, again, as I tap and hold and move around the map, we can see that the routes are generated basically as quickly as I can move. And we're just showing the route. We're getting turn-by-turn directions, but we don't have a place where we're showing them. And then some kind of summary information about that. And if we wanted to, we could add in barriers, we could point polygon or line barriers, and we could use those and include those inside of our route as well. Jumping over to the code. Again, same kind of pattern that we just saw. See here, we're setting up our route task, passing in the path of the database that we have on disk, and the name of the network that we want to use from that data set. Then, when we did our tap and hold again on the map view, we call calculate route. And if we go down to calculate route, so at the beginning we do kind of a little bit of cleanup of the previous graphic layers. But it starts to get interesting, really, where we're starting to set up our route parameters. And so we're going through and putting, if we had multiple stops defined, we're adding those as parameters. If we define barriers, those kind of things, they all get added into the parameters. This is also the point in time where we can start to set up things like Ewan had mentioned. If we want to preserve sequences or first and last stops, finding best sequences if we wanted to reorder them. So all of these things are options that we can define on our parameters before we actually kick off our solve. So here we're basically relatively simple. We only had 2 stops, so there's not a lot of the options that we actually will affect the results that we get back. But we do want some summary information. We do want our directions. And then finally, after we've set up our parameters, we call solve. And when the solve is completed, when solve completes, we get back a root result. And with that, we can pull out some basic information like our total miles and minutes, the information that we were showing on the callout underneath of our map cursor. And then we can also add the graphic to our graphic layer and actually show that the blue line, our turn-by-turn directions on the map. So simple example of how you can do routing inside of the runtime.
Thanks, Justin. All right. So app development, preparing the data, writing the code, that's all obviously critically important. But when you're building applications for offline use, there's other things that you've got to think about. And depending on the devices that you're targeting, you can have a more challenging space than others. For instance, on iOS and Android devices, the operating system can just come along and take down your application if it's not the current one, even if you thought it was running in the background. So you've got to make sure that you can deal with that. So when you start to do things and you start to talk to the server, remember you started that operation and you get a job ID often, store it locally so that you can always pick it up from where it was at when your application got killed off. Deal with the synchronization failures. And it says apparent synchronization failure. The failure is in the sort of that process. Some part of that multi-step process, something happened and we got a failure. So then make sure that you've remembered the job ID of the start of that process so you can always come back and restart it and continue through to conclusion at the end. And obviously think about the data sizes, think about your user's network connection. Maybe think about limiting what size of packages or data that they can download depending on which data network connection they've got. If you look at the ArcGIS collector application, which is built on top of the runtime using this technology that we're showing you today, it has a limit, I think, of 100 megabytes if you're on 3G or 4G. And then after that, you're going to be asked, do you want to allow that? And it's an option that you have to go in to say, turn it on, and I'm prepared to download larger packages, etc. So when it comes to licensing, today there's 2 license levels in the runtime. There is the basic license, which is a no-cost deployment, and then there's the standard license, which there's a cost associated with that. And for basic license, you can use it to view maps and download content from online or portal. So that content can be the raster basemaps, it can be the features, but you can view that online or offline for no cost. If you want to start editing that content, that's when you need a standard license for the runtime. Or if you want to do geocoding or networking disconnected, you need a standard license. And there's 2 ways that you can, as a developer, work with a standard license. You can purchase from Esri license deployment packs and burn the license into your application. That's good. Your users don't really know that's happening. They just start the application. Or you can ask your users to sign in using their named user account. If they sign in with their named user account, it unlocks standard runtime capabilities. So if you're working within an organization that has named users, there's no additional cost to get access to this capability. When it comes to working offline, standard named users can go offline for 30 days before their, if you like, temporary borrowing of the license times out. So they've got to reconnect within 30 days to restart that clock. But it does allow them to go out into the field disconnected for up to 30 days. And it's a very attractive model for developers. So that's everything that we've shown you today is what you can do right now. If you go to the developers website, developers.arcgis.com, you can download any of the SDKs that we've showed you. You can actually download the sample apps and compile them, and you can experiment with a lot of the samples like Justin and Will were doing. But we are working on a significant release, codenamed Quartz. It's out in beta. All the SDKs got released just last Monday with their final beta before we go to the final release, which will be in November next year, before Thanksgiving. And it's a significant release. And a lot of the effort that we've been putting into it is adding more and more capabilities to the runtime so that you can do more and more things while you're disconnected from the platform. So there's two big goals to the Quartz release. One was to enhance the runtime itself, to add capabilities, and the other one was to really make the runtime an alternative to engine developers. And we feel that at Quartz we've hit the critical mass so that the majority of engine developers will now be able to move over to the runtime technology. You can work with maps offline at Quartz. What we've really been looking at so far has been working with individual layers offline, basemap layers, feature layers, but not really talking about taking a map offline. Well, at Quartz, you'll be able to take maps offline, and you get the beautiful cartography that you've authored in Pro or you've authored in online, and you get all of that comes down as part of the map. So we're now really talking about working with maps. You can author maps in your application. You can push these maps to online, or you could open these maps up inside of Pro, because we all share the same map specification across the platform. It's going to make it very easy for you as developers to build applications that integrate within your organization's workflows, because you can all center on that same common map. Work with mobile map packages. That's the next generation of the create runtime content. It's an even better experience and a better format for getting data from your desktop in Pro into a runtime application. And when you're working offline, it's not just about 2D content offline, it's also about 3D content. So you'll be able to build 3D applications that work disconnected as well. And to give us a sneak peek into...
Just because we know Ewan really likes to have the impromptu changes made during the session.
Okay.
That's, we'll come on in a second, but very quickly we thought it was worthwhile to show a little bit about the mobile map packages.
All right.
So as Ewan said, mobile map packages kind of are the next generation of create runtime content. And it really is a big step forward. And with create runtime content, we kind of got that folder output that you needed to bring over to your app and kind of bring it back to life. And there was a bit of work to be done there. And it's really good, but in Pro, we've started to make it a little bit better. So we see I have a slightly different map. I have some wind turbines, and I have a custom road network. And I zoom out, kind of symbology changes. There's actually some really nice base map data, all vector data, coming from the Esri Street Map Premium data set with some nice cartography, far nicer than I could ever do, living underneath of it. You can tell I made the windmills because they're little yellow plain dots, all sitting underneath of this. And again, we have a network in here that matches my custom street network that I had, as well as transportation network coming from the data product that we can merge together. And I have a locator added inside of the project as well. So inside of Pro, the tool is now called Create Mobile Map Package. And from here, I can select the map document that we've just authored here, choose the output location if I want to include the locators, et cetera, and then package it up. And when this packaging happens, now rather than getting a folder of output, we actually get a mobile map package. And that single item contains the data, so the geodatabases, all the features, if there was tiles in the future, the near future hopefully, vector tiles, your locator, your network data set, all of that. But the biggest addition is we also get the map as well. And then that package can be shared on ArcGIS online or, again, sideloaded onto your device. So if we just look at the output of that tool, it's just one thing. And inside of it is all of this data that we talked about. So rather than you having to rebuild the map inside of code, you'll just be able to take this over inside of your runtime-based application and then call something to open up the map. And then from there, we'll get the exact same map with the same symbology, all of the kind of the same stuff that we authored inside of Pro. If we can zoom out, we can see we have that whole data set that's been brought over. And it all works really nice and smooth with a whole lot less code now inside of the Quartz release of Runtime. All right, and with that, now I will switch over to Will.
Okay, what we're going to do now is just have a quick look at some of the other capabilities that Ewan was talking about that are coming in Quartz, such as taking maps offline and local data support. So we should see, okay, so here's an application that we built that opens up maps from my portal. Okay, these are not layers, these are all the map documents, web maps that are shared with me in my ArcGIS Online account. I'm going to open up one that's in DC. It's got a vector base map, it's a night streets map, and it's got some operational data with some of the smart mapping capabilities, rendering symbols based on attributes and size and multiple renderers and things like that. Now, as Ewan said, in previous versions of the runtime, you as a developer could take layers offline, and you had to write your code to loop through the layers in your map and take each individual layer offline, work out their type, work out which task to use based on that layer type. In Quartz, what we're working on is a button on the bottom left, which takes your map offline. So we're working on something called the offline map task, currently designing it out and prototyping it. And that does all of that heavy lifting for you. It goes through, figures out the layer types, figures out the tasks, takes that data offline and saves it locally. So that then allows me to work with the map in an offline mode. The other thing we're looking at and working on is the capability of then you being able to share that map with other people out in the field. So when we take this map offline, we're currently going to be taking it offline in the same format as the mobile map package that you just saw Justin work with. So that means we can consolidate this into a mobile map package so that you can share it with other users. So if I'm out in the field with an offline map that I've taken offline, I can now actually package it up and share it with someone else. And I'm going to attempt to do that through AirDrop right now, if my machine shows me. So look, it takes a little bit of time. But this is one of the workflows that people have been telling us that you're interested in being able to share data. So TOE is the name of my laptop. So I can send it to TOE, which is number 4. And this is basically connecting to my device, taking that mobile map package, sending it over. And if I talk really slowly, it might get there. So you can see I'm here, I'm waiting for Esri's iPad to send it to me, but it's not going to work, is it? Luckily, like Blue Peter, I have a mobile map package that I transferred earlier. Ooh, look at that, delightful. Not sure what's going on with the symbol size there. It looked fine when I weren't plugged into the projector, but the symbol sizing and the DPI has obviously thrown it off a little bit. But basically, it's the same map with different symbology showing on my Mac. So that's one of the capabilities, being able to basically take data offline and share it around with the concept of mobile map packages. And the concept of mobile map packages is important for sharing data, whether you've published it from Pro or whether you're taking maps offline and sharing it between runtime applications. So the next thing I want to show you is some other of the capabilities coming in Quartz, which is local data access. So this is the ability just to have different data files on your device. Local data files not come from an ArcGIS application. So these are workflows where you're getting information and data from potentially non-ArcGIS sources, shape files, raster files, all types of data, and you just want to add them to your maps. So this phone is in airplane mode, so you can trust me on that one. And this is actually opening up Landsat multispectral data from a raster file on disk. So there's no internet connection here, and this is just direct read of raster data. So my base map is just purely raster data. And I can go through and add geodatabases. So that's a mobile geodatabase shared from ArcGIS Pro. Comes with the symbology as well. We package the symbology inside, so it's not like a shapefile that comes with a default. It's not a particularly exciting symbol, but it is a symbol nonetheless that's been authored in in ArcGIS Pro. So I can also go and add in other data files that you might be familiar with, shapefiles. So this is a shapefile that I downloaded from the Government of Hawaii website. It's a wind speed. Put it on the device. So you can send shapefiles to each other and just add them to your application. Can also add a KML file that someone sent me, an offline KML file. I think it's that one. And this is a KML file with, I think it's wind speed, cloud cover, and it's got a screen overlay on the right-hand side, so you can see as I don't move the map, the screen overlay stays there, which is essentially as my legend. And then it's also got some raster data representing, I think it was cloud cover for that island at a particular point in time. And if that KML file had network links in it and I had a connection, we would refresh those network links and get all that for you on the device. The other thing, obviously, is because I've got raster data on my device, we have the ability to change your raster renderers. So you can actually look at different ways of showing that multispectral and multi-band data. So in this case, I'm going to look at an RGB renderer. Again, this is all happening on the fly on the device. It helps me understand the vegetation buildup of the island. But if I want to blend that with the digital elevation model that I've also got on the device, I can apply a blend renderer, and that's a composite of both the RGB and the digital elevation model, and it allows me to see the topography and vegetation cover in one go for the island of Hawaii. So that's just another sort of power of things that you can do with local data and local raster files that we're building into the runtime at Quartz. So those are the Quartz demos.
All right. So I too can make changes on the fly. So thank you, Will and Justin,
Nice.
for these demonstrations. All right. So that's the end of the session. If you're interested in some of the more details on what's happening in Quartz, we've got a road ahead session tomorrow, and we'll go into a lot more of the details. We'll cover 3D in detail, etc. We've got 2 or 3 minutes left for questions, but please don't forget to fill in the sessions, the survey. You can find it in the app, the events app. Find the session and give us some feedback. Tell us what you liked and what you didn't like. Hopefully you liked it all. But if you didn't, we want to hear about it too.
Good or bad, it's all good.
Any questions? Question at the front.
So with Quartz, is it only going to be ArcGIS Pro where you can render that or output that mobile map?
So the question is with the Quartz release and its support for mobile map packages, is it only ArcGIS Pro that you can use to create the mobile map package? The answer to that is yes. However, if you do most of your cartography work and most of your data preparation work using ArcMap, it's very easy to start up Pro, import the MXD, and then create your mobile map package. It's not seamless from ArcMap, but it's a very easy operation to do. And the import of an MXD to Pro happens pretty easily, quite quickly. Question here? So the question is, does create runtime content honor layer visibility? Well, there's some parts of there are some things there are some layer properties that are honored in create runtime content, but not all of the layer properties are honored. The symbology is honored because that comes over into the mobile geodatabase, but some of the relationships and sort of the layer ordering, etc., you're not creating a map at that point. All you're doing is you're taking the individual layers and their data and the symbology for the data, Not everything is created. That's why the mobile map package is really what we're really looking forward to, because there, all the map content, all the layer properties, the layer ordering, etc. If you have a map that is talking to multiple geodatabases, that all comes across in a mobile map package. Whereas with create runtime content, there's some limitations because it wasn't the map that we were taking. We didn't have a map class or a map construct until the Quartz release. So that's where we really recommend you would move towards the Quartz release with mobile map packages.
So when you create enough, like right now with mobile data services, if you make even the most minor schema changes, if you add field on the server, it basically breaks the schema process. Will that occur with the new offline geodatabase? So if I made a minor schema change on the server, is that going to break sync completely, and I need to download a brand new?
I think we have the same limitations. Justin,
it's the same kind of thing. It's recommended that after you've deployed and you have people working with it, that you do not make schema changes, because we synchronize data, we don't synchronize schema changes. Technically, you get...
I understand they want to be synchronized, but will you still be able to kind of synchronize the data?
It's not a supported workflow to do that. Your mileage may vary. There is a possibility, if you say add in a new field, then you can technically get your stuff back in, but it's not something that we promote as a workflow. It's not something that we support, but there are some things that can happen, so you can at least get your data back after you've made them. But it's recommended you have a workflow where you'd have to be publishing another service, doing a switch over, keeping the old one around. There are schemes that we have worked with customers in the past on recommended workflows with that, and it's very similar to the Windows Mobile days with the mobile service as well. Same kind of recommendations. Yeah.
Along those lines, what would be really nice is if you could create that offline, that replica on the server, and then everybody else downloads it, as opposed to everybody else.
So the question is about pre-planned workflows with server, and yes, I completely agree, and it is something that we're working towards, actually. Yeah, it's something that would really help with, as Ewan said, if you have a whole workforce showing up at 9 a.m. in the morning, you don't want all of them to create the exact same thing. You want to do it once, and then get it, and then register that as an individual replica on the device so that you can then do synchronization. Definitely something that we're going to...
Yeah, that is an active development project. So a lot of the underlying technology all supports that. But what we don't have is the tooling in order to do that operation on the server and the nice user experience to say, take this area, pre-cook it, cache it on the server, and allow my clients to sort of pick it up. So that aspect is, there's an active development project, and that'll be sort of rolling out. That'll be a 2017 delivery, though.
And then actually just a little bit more on that one, is you can accomplish that workflow today. You can use runtime to export a geodatabase, and then all of the APIs have a register operation on their geodatabase or on the geodatabase sync task. So you can actually, while we don't have like making it really nice, what Ewan was talking about with server, you can accomplish that workflow today. You can create it, stage it somewhere, and call register and make it work.
So did you follow?
At least when I've tried it, it didn't work with the geodatabase.
No, you should be able to do that on a version. You should be able to do that on a version.
We can talk afterwards.
But what Justin was talking about, you actually you build a custom application in runtime to create the offline cache, if you like, and then you can distribute that to many machines, but each application has to call register replica, and so that they all then can start using it in the sync operation. Question here at the front?
Will the Quartz release or any other future releases will support like a perspective map view or navigation application?
Okay, so the question is to do with sort of in-car navigation, and sort of, we call it a 2.5D view, where it's not a true 3D view, and it's not your typical straight down perspective mode. Will we support that? We have no plans to support it. With the 3D runtime, it is possible to build a UI, a user experience, where you just lock the camera at a certain angle, and you follow a route, for instance, if you wanted to build something like that. You could build that with our 3D engine, which is in Quartz. Yes, yes, you would be able to do that. But we don't have the 2D view. Any other questions? All right, well, thank you very much for coming. It's been a pleasure.